Hi everyone, welcome to XCA Xcoding with Alvian. In this video, we're going to build an AirQuality Index iOS app that shows air quality conditions around a given location in a map. It uses universal AQI standard for the index and shows the dominant pollutant as well as the color. And we're going to use the new SwiftUI native map view, which is new in iOS 17. And for the data, we're going to use the new Google Air Quality API. This app provides robust and reliable air quality data that help us to monitor and be aware of pollution around us, as the quality of air that we breathe continues to worsen day by day because of climate change around the world. Let me show you a quick demo of the app that we are going to build in this video. So let me just kill this and launch the app for the first time. So when we launch the app for the first time, the app will ask for the location authorization. In this case, I already given the authorization to get the current location. So this is my current location. I'm currently located in Jakarta, Indonesia. As you can see, the air quality conditions in Jakarta is not very good. It's quite bad. And we can play around. So we can tap on one of the coordinate. It shows this universal AQI as the standard. So now it shows 23, which is low air quality, and the dominant pollutant is PM25. Okay, so if you see, wow, it's quite bad when we are using the AQI standard, universal AQI standard. We can also provide our own coordinate in here in case we want to find conditions given latitude and longitude. So let me give this location. So I'm going to give the coordinate of Kowloon in Hong Kong. Okay, this is the coordinate. And let me click this refresh air quality. Okay, it goes to Hong Kong and fetch the air quality conditions around Kowloon. As you can see, the weather in Kowloon is much better compared in Jakarta, right? The dominant pollutant is NO2. Okay, this is using the universal AQI as the matrix. Okay, there are several different metrics, but for our app, we are going to use the default one, which is universal AQI. So this is it, the application that we are going to build. We're going to use SwiftUI native map view, which is new in iOS 17 to build this. Now, let me just close the simulator. So before you begin, there are several requirements. First, you need to install Xcode 15 and also download the iOS 17 simulator as well. Okay, so let me create a new project using Xcode 15. Okay, let me move the window. Okay, so this is the new project template. Select iOS from here and select application, click next. For the product name, I'm going to give it name of XCAAQI Index. You can provide any name that you want. Select your team, provide your organization identifier. Make sure to select SwiftUI. For the interface, language Swift. And for the storage, just select none. And just uncheck include test for now. Click next. Select the folder that you want to save the project. And okay, we got the initial template for the app rendered to us. The first thing that we are going to do is we're going to add a SPM dependencies. Okay, so go to this XCAAQI Index project and then select package dependencies. Click this plus button. And I'm going to provide the GitHub repository for this XCAAQI client that I have created. So this is basically a simple wrapper for the Google Air Quality API that is generated using Open API Generator Swift client. So this generates the client code and the type for us. Copy the GitHub repository and provide it in here. I've already added here XCAAQI for me. But for you, you can just copy the link that I provided in the description. Okay, click next. It's going to fetch the dependencies. Okay, make sure this library is added to the XCAAQI index target. Click add package. Okay, it's going to provide download the dependencies and all of its separate dependencies. If you can see in here, this is the XCAAQI. So in the sources, you can see there will be an open API for the Google Air Quality. So this is just a simple open API file that I have created myself, and it only provides one endpoint. Okay, so in the actual Google Air Quality API, there are three endpoints for the getting the current conditions, historical data, as well as the heat map. But for this tutorial, we're going to only use this current condition endpoint given a coordinate. Okay, so this will generate the Swift code automatically for us, and we can simply import the XCAAQI and use this air quality client in our application. Okay, so first let's try to build first. Make sure there's no issue. Select iPhone 15 simulator and build. Let's wait for it to complete. Okay, the build succeeded. It takes some time because there are a lot of dependencies used by the Swift Open API generator, as you can see, to generate the Swift client and type using that Open API YAML. Okay, but now we should be able to just import the XCAAQI and use the air quality client without writing the networking and JSON parsing code by ourselves. The first thing that we are going to do is to create the view model for our app. We're going to just have one view model for this. So create a new Swift file, give it a name of app view model. Okay, and let's import. First one is MapKit and observation framework, and of course SwiftUI, and as well as the XCAAQI. Okay, and first one is let's use this observable macro for this view model. Okay, give it a name of app view model and make this as a class. First, let's just declare and let AQI client and then assign it with the AirQuality client, passing your API key. I'm going to provide my API key from the GCP with the AirQuality API enabled. Okay, so this is for my account, but for you, just create your own account and create your own API key. Of course, I will revoke this key after I publish this video, okay? So you won't be able to use this. Okay, next one is of our current location. This is to store our current coordinate that we get from the GPS location manager. Okay, and next one is the position of the camera that is going to be used by the map view in SwiftUI. The type of this is map camera position. It's a structure that describes how to position the map's camera view within the maps. So there are several options. If you see, there's an automatic, the position that frames the map content, and there is also a user location. It creates a camera position with a specific fallback position and optionally follow the user heading. Okay, for us, we're going to initialize this first with the automatic, but later we're going to assign it using this region when we get the location. And next one, let's create an array for annotations. This will be a tuple containing the coordinate 2D as well as the AQI index. We're going to stop this initially, okay, for all the coordinates that we want to show around our current location. Okay, so let's now create an initializer, and in the initializer I'm going to just stop the position for starter so we can play around with the map. We'll implement the location manager course authorization a bit later in the video. Okay, so for this, let's save the current location first using this CL location coordinate 2D. I'm just going to provide a hard-coded value. In this case, I'm going to use my location in Indonesia, which is this location in Jakarta, Central This is district. Okay, so this is the coordinate. It should be double instead of string. Okay, you can also provide your own coordinate if you want to use another location for the stop. Okay, and for the position, let's set it to region. Okay, assigning this one center. For the center, let's just pass the current location. Okay, just first unwrap this. And for the latitudinal matters, let's just pass 0. And for the longitudinal matters, let's just pass 16,000. Okay, so these latitudinal matters and longitudinal matters will determine the zoom level in the map. You can play around later for you to find the best zoom position that you want. Okay, so this is the initializer for the app view model. Now let's move on to the content view. In the content view, let's just declare the var using this state property wrapper for the PVM. And let's initialize the app view model in here. Let's wait for the preview to be shown in here. Okay, we have the view shown in the preview. Now let's just remove all the code in the body, and now let's just, we need to import MapKit, okay, to access the SwiftUI map view. MapKit, and then in here just declare map, and here there are several initializer. There are these initial position, bounds, position, coordinate region. For us, we are going to use the camera position initializer, so this one. For the position, let's pass this as a binding. Okay, we already have that in the view model, right? So we can access this passing this as a binding, which is the position var. It's a map camera position type. Okay, so this will determine the position, the map. As you can see, it's the coordinate of my location, which is in central Jakarta. Okay, so we got the map, and to show our current location as a pin in the map, it's very simple. As you can see now, we can simply define this marker. Okay, let's just pass like current location, my location, my location, and for the coordinate, we can just pass this current location, and just force unwrap this because we are currently stubbing this. As you can see, it shows this my locations as a pin inside this map. It's fairly simple, right, to show the marker or annotation. So this is the default marker. It will be shown as a pin, and there are several modifiers you can play around as well. Like if you want to hide the title, you can use this by passing hidden in here. It will hide that label. Okay, and now let me show you several options that we can provide to customize the map style in here. So this is the default map style, as you can see, but we can actually customize this using this map style modifier. Okay, there are several modifiers, which is imagery. It will show it like this, and for us, we're going to use this hybrid one. Okay, so you can also customize the elevation if you want. Make it flat, make it realistic, and for us, we're just going to make it flat. Okay, we don't want to show any elevations. For the point of interest, we're just going to show all the point of interest, and for source traffic, we will pass false, as we don't need to show the traffic. As you can see, now it shows all the points of interest. This is Central Jakarta, East Jakarta, South Jakarta, right? It will show the labels for all the points of interest. Amazing, right? So other than this map style, we can also pass this map control. Okay, in this case, we need to pass the closure. In here, we can provide the controls that we want to be shown at the top right. In this case, we can use this. I want to show the location button. As you can see, now it is shown in the top right. And I want to also show the map compass. Okay, it's not being shown in the preview. I'm not sure, maybe because of the simulator doesn't have the compass as a hardware, right? But in the real device, it's going to be shown, this compass button. Okay, and I think there's also a map pitch toggle, a button that says the pitch of the associated map, in case that if you want to show this as a controls. Okay, so these are the customization that we can pass to the SwiftUI map view. I think it's really amazing for this API. Now we can access the map directly without wrapping it inside a UI view representable, and the API looks very clean and easy to use as well. Now let's add a navigation bar first to this content view. I'm going to navigate to the entry point XCAAQI Index app, and then I'm going to wrap this inside a navigation stack, this content view. So we only have one main view, and also I'm going to do that inside the preview as well. Okay, let's try to build. Okay, resume the preview. Okay, it doesn't show the navigation title yet, but now let's add a navigation title. I'm going to give it a name of XCAAQI AirQuality Index. Nice. Okay, it's too big. I'm going to just display this as an inline. Okay, and I'm going to also blur the background for the navigation bar using this toolbar background. Okay, for the visibility, we can pass ultra thin material, and we can pass navigation bar for the placement. Okay, nice. Now we have that blurred navigation bar showing the title of our application. Okay, so we have shown our location in the map, as you can see in here. And for this app, we want to basically get coordinates around a given location. So given the center coordinate, we want to calculate coordinates around this. So we're going to utilize a naive approach to calculate the coordinates given a single location using a circle. Okay, so let's say we give an input of 4,000 as a radius, so it will create the radius of 4,000, and then given a 4,000, we want to generate like 6 coordinates. It will basically use that radius to generate 6 coordinates around that radius. So we're going to have multiple radius, 4,000, 8,000. Maybe for 8,000 we want to generate 12 coordinates. So we're going to basically use a formula for that I get actually from ChatGPT. Okay, so we're going to basically just use that, provide the input, and it will generate the array of coordinates for us. Amazing, right? So this is a naive approach to get the coordinates given a location. But in your production application, I think you should use a predetermined coordinates, the coordinates that you really want to track the air quality conditions, right? Because the billing for this can be a bit costly, because Google Air Quality API will count one coordinate to one API call, and I think like it costs like $5 per 1,000 API calls. So you need to be careful with that. I will share another approach that we can use to handle that later when we add the fetch data using the Google Air Quality Conditions API. But for now, let's just generate the coordinates using that formula. Okay, so let's create a new Swift file. So let's just give it a name of coordinates finder. Okay, I'm going to just copy and paste this code from the completed project. So the link to the completed project will be provided at the description. So you can also copy and paste this. So this code actually is generated by ChatGPT. Okay, just to be honest with you. So as you can see in here, this is the coordinates finder. It defines several constants, function to convert, helper functions, and this is the function that we will call. So define a function to define coordinates on a circle on a given point. We'll pass this single coordinate as well as the radius and the number of coordinates we want to generate around that circle. Okay, and yeah, this is the formula actually, if you want to look into the detail on how this is calculated. So this is the coordinates finder. Now we have this. Let's go back to the app view model. Okay, so in the app view model, let's just create another let in here, give the name of coordinates finder, and then initialize it with the default value of coordinates finder. And for the array of radius and the number of coordinates, I'm going to declare this as a property in here. So I'm going to give the name a radius and array. Okay, so this will just be an array of tuple. So this double will be the radius, and this integer will be the number of coordinates that we want to generate. And for the default value in here, it will be 4000 as a radius, and given 4000 we want to get 6 coordinates, and second, given 8000 as radius, we want to generate 12 coordinates. Okay, that's the default value. And let's pass this in the initializer. Okay, so I think the default value should be in the initializer. And then let's assign this radius and array with the parameter in the initializer. So this can be overridden if you want. Okay, but be careful with the number of API calls. I will explain that a bit later. So let's start to build first. Okay, the build succeeded. So to generate the location first, I'm going to create a temporary struct. Okay, in this instance, I'm going to just generate a struct of location, the type of identifiable, and I'm going to assign the ID, UID, and second one is coordinate, CL location coordinate, the 2D, and also the AQI index, the type of string. So this is just a temporal location that we are going to stop. Later we are going to use the real AQI response model from the XCAAQI framework. Okay, so let's replace this annotation with the array of location. Now let's declare a function in here, give the name of handle coordinate change. Okay, let's pass the coordinate as the parameter, CL location coordinate 2D. Okay, so inside here I'm going to move this position, self.position, inside this method. Okay, and replace the center with the coordinate from the parameter. Okay, and in the initializer I'm going to invoke this handle coordinate change, passing the current location. First unwrap this. Okay, so next let's create another function again, get coordinates around. In this case the parameter is also a CL location coordinate 2D, and it will return the array of CL location coordinate 2D. So this will be the method that interact with the coordinate finder. So in here let's just declare our results var. It will be an array of CL location coordinate 2D. In this instance we are going to assign it with the default value of our current coordinate, the center. Okay, this is the center coordinate, and in here we can simply invoke this radius and array. Okay, invoke for each, and then in the for each we can just append this array by invoking coordinates finder find coordinates. Okay, if you can see, we can pass the coordinate, the array or center coordinate, and pass the radius. In this case it should be the first one in the tuple, and for the number of coordinates is the second one. It will append it to the array, and finally we can return the results array. And now let's go back to this handle coordinate change. In this handle coordinate change we can assign the annotation by invoking get coordinates around coordinate. Okay, it will return the array of coordinate, which we will just invoke map. In this case we want to just convert this to the location. Okay. And for the AQI index, for now, I'm just going to generate this using a random number. Let's use string interpolation and create a range starting from 50 to 150. Okay, and get the this inner parenthesis random element. Just first unwrap this. So let's just stop the AQI index number for now, so it can be shown in the UI. Okay, now we have these annotations. Currently, the AQI index is stopped, but we have implemented a way to get the coordinates around a single center coordinates, given a multiple radius and number of coordinates that we can create given that radius. Okay, now let's try this in the view. Navigate to the content view. Okay, the first thing that we are going to do is to create a circle view, because we are going to use a circle view. So the circle will stroke it with the color of the key conditions, as well as showing the label at the center of that circle. Okay, so let's create a new SwiftUI view. Give it a name of circle AQI view. So in here, I'm just going to import XCAAQI, and let's resume the preview. Okay, we got the preview. So for this, I'm going to change the color scheme to dark appearance, and for the struct, we're going to inject it with the AQI response. Okay, and also I'm going to add an isSelected boolean to determine whether that current circle annotation is selected or not. And then size, CG size, we're going to use this to set the frame width and height. So let's initialize this with the default value of 44 by 44. Okay, for the width and height. Now for the circle AQI view, we can just pass the stop in the preview. For the selected, let's pass false as the default value. Okay, let's just stop the AQI in here. So let's provide the stop AQI display. Let's pass 23, and for the color, let's pass like init red 0.5, green 0.5, and blue 0.5. Okay, now let's implement the body in here. Let's just create a circle. Okay, and then let's set the frame to size.width and height to size.height. Okay, and we're going to add a stroke in here. We're going to initialize the SwiftUI color wrap. Let's pass AQI.color.red, green AQI.color.green, and blue AQI.color.blue. Okay, we got the stroke, and let's set the line width for this. If it is selected, we're going to set the width to 4, and if it's not selected, set the width to 3. Okay, nice, we got the circle. Now let's put the label. Let's use this overlay, and for the content, let's just declare text AQI display string, and set the foreground style to white, and set the font weight to bold. Okay, nice, we got it, as you can see in here. And let's also add a scale effect. Okay, in case it is selected, it's going to set the CG size. We're going to scale it to 1.5, and in case it's not selected, we're just going to pass the default one with and head to 1. Okay, so in case we pass this selected through, it should be bigger. Nice. Okay, looks nice. If you play around with this red, you can see the color change. Amazing, right? Okay, we got the circle AQI view. Now let's go back to the content view to use this. First, let's just remove this marker. Okay, so let me resize back the preview. Okay, so inside this map, we can simply use for each passing this vm.annotations, okay, containing the location. Give it the name of AQI in. So for the annotation, so we're going to use this one, title, coordinate, and content. For the title, let's just pass empty string for now. And for the coordinate, let's pass AQI.coordinate. And for the content, we can provide our own view. And inside here, we're going to just declare our own view, which is the circle AQI view. Okay, we need to map this to this AQI. So let's just pass AQI display of AQI.AQI index. So this is currently random, right? Now let's resume the preview. Nice. It shows the location. Currently the color is not being represented because we haven't stopped the color, right? But when we fetch the data from the Google AirQuality API, it will provide the RGB color that we can assign to the stroke color of the circle view. As you can see, our algorithm to find the coordinates using that radius, multiple radius works. So this is the center, and this is the, I think, let's see, forgot it. And we said that radius, so we use 4,000 and 8,000, right? So this is the 4,000. We got like 4 coordinates. 1, 2, 3, 4, 5, 6. 6 coordinates, sorry. And for the radius of 8,000, so this is radius of 8,000, it's a circle. It's going to generate 12 coordinates using that coordinate finder method. Okay, so we have generated these coordinates around using that coordinate finder. And one thing also, this annotation, right? If we put the number in here, the title, currently it's going to show this, which we don't want because we already show the title at the center. So we can use this initiation titles and hide the annotation title, okay? Because it's a bit redundant to show the AQI display twice inside and below the circle. Now we're ready to call the Google AirQuality API to get the current air quality conditions data from the Google AirQuality API in real time. But before that, let me show you several pages related to this AirQuality API overview. So this is the AirQuality API overview page documentation. So actually there are 3 endpoints, as you can see: current condition, early history, and heat maps. For our app, we're just going to use this current condition, right? And yeah, it provides you the example as well on the how to make the API call, the request body. So it's a post HTTP call, and these are all the parameters that you can pass. So this is being generated by the SwiftUI API client for us, but actually for now we can only pass the location. Okay, I haven't added the parameter to pass additional request parameter in here, so maybe I can add that later to the SPM package. Okay, So this is the AirQuality API documentation. I provide the link in the description. Now let's move on to the pricing. Okay, so for the pricing, first you need to enable billing to your GCP account. Enable billing because it uses the pay-as-you-go pricing model. And this is the SKU pricing. As you can see, between 0 to 100,000, it costs around $5 per 1,000 requests. Okay, and for $1 per 1,000 requests for between 100,000 to 500,000. Okay, so as you can see, we need to be careful in here because each of these call to this circle, right, will be built to one API call. So if we have this like 20 API calls when we launch the app, it will be counted to like 20 right in here. And let's say we have like 100 users opening the app at the same time, then it will cost us $5. Okay, so yeah, the approach that we use in the application itself to get the coordinates around this location and making the parallel API calls to this endpoint, right, to get the AKI conditions. It's just an example for this video, right, because we are going just to demo how to integrate SwiftUI map view, right? And I don't really recommend you to use this approach directly in your production app unless you can justify the cost, right? If you have like large number of users, it can be quite a bit costly, right? One approach that I can think of to achieve a better cost efficiency for scalability as your app grow is to deploy your own proxy server that communicates with this Google AirQuality API, right? You just need to predetermine the coordinates, topmost coordinates that you want to cache, and then maybe you can schedule a cron job within an interval, maybe between 2 hours, 3 hours, every 2 hours, 3 hours to get the condition from those predetermined coordinates from the Google AirQuality API, and then cache the results right to your database. Okay, any database that you can use. So basically, the mobile app itself will make the request to the proxy server instead of the Google Cloud AirQuality API. And basically, with that, you should be able to reduce the cost, right? Because it will just use the cache data from your server. And it will be much cheaper to just deploy that server. And it is easier to scale that server in the long run, right? Instead of paying this $5 per 1,000. I think if you make 500,000 epic calls, the volume pricing will be a bit different. You will need contact sales. Maybe it can be cheaper, okay? But yeah, that is just one approach that I can think of if you want to roll this app out in production, right? Just like using that browser server. There are maybe more alternatives that you can use, and maybe you can provide that if you want to comment at the comment box below. Okay, now let me show you. First you need to enable the API in your GCP console. So this is my GCP console. This is the project. The name of my project is BigQuery. So just go to the APIs and servers. So you can also select this from here, I think. API and service, okay. And you go to here, API and service. So it will show the API call. As you can see, for the AirQuality API, I already make like 130 API calls. It's quite big, right? Remember, 1,000 requests will cost you $5. Okay, so we need to be careful. And then you can just click this Enable API and Service, and then just search for Google AirQuality. AirQuality API Google. For me, I have enabled this, right, for my project. Okay, and after you enable this, you can basically create a API key for your application. So go to the IAM and admin panel in here, and from here you can basically or maybe you can search from here API keys. Okay, select this. Okay, this is the API key, so you can just create your API key in here, create credentials, select API key, and then it will create the API key for you that you can just copy and provide that in the application. Okay, so this is how you enable the Google AirQuality API from the GCP console, as well as creating the API key that you can use in the application. Okay, now let's go back to the app view model. So this is the API key that I passed to the air quality client that will be used when making the HTTP call to the Google Air Quality API. Okay, the first thing that I want to do is I want to just delete this temporary struct location and then replace this annotation with the AQI response. Okay, let me just comment this code first, and also in the view, let's replace this with the AQI display. Okay, so this is a key response now, and in here we can pass the AQI because this is already AQI response. Okay, so let's go back. Let's try to build first. Okay, the build succeeded. Now we already update the annotation to use a key response. Now let's create an enum to help us represent the state of the UI related to the view model, right? So let's give a name of enum location status. Okay, so let's make this conform to echo table. So we will have several states. So later we will implement request location authorization. So let's create one case of requesting location case. Second one is location not authorized with a associated value of string, the reason, and error. Associated value of string as well, showing the error text. And the case for requesting AQI conditions to the Google Air Quality API. And finally, we have a standby case. Okay, this is the like an idle state. And now let's declare this location status here inside the view model, location status. So the location status, initial location status will be requesting location. Okay, the next thing that we need to do is to update this handle coordinate change to an async throwing function. Okay, and then inside this initializer, okay, because we are not going to implement the location request first right now, let's create detached task. And so let's not make this throwing, actually just make this async and just invoke await solve handle coordinate change. Okay, let's build. Okay, build succeeded. Now inside this handle coordinate change, let's declare a do try catch. In the catch, let's set the location status to an error, passing error.localized description. And let's move this code inside this do block. The first thing that we're going to do in the do block is to update the location status state to requesting AQI conditions. Okay, and next we set the position. Okay, it's already there, the code. And next one is let's declare let coordinates. In this instance, we're going to invoke get coordinates. This will get the coordinates from the coordinates finder utility. Pass the coordinate in here. We got this array, and now we can invoke, we can declare AQI responses let. In this case, we are going to invoke using try await AQI client. Okay, this is from the XCAAQI SPM, and there are two methods. So this is for a single location. We just need to pass the latitude and longitude. It will return a single AQI response. And in here we can pass an array of this latitude and longitude tuple. This will return an array of AQI response. So this is the one that we want to use. Remember that total element in this array will be counted toward the number of API requests to the Google AirQuality API in your billing. Okay, so you need to be careful. Don't pass 1000 requests within a single array, right? Okay, just be careful. I just want to say you can also enable quota limitation to basically limit the daily quota for this API usage in the Google AirQuality API. Check the documentation on how to do that. Okay, for the coordinates, we can simply pass these coordinates. Okay, so this is the allocation coordinate 2D, but it expects an array of tuple, so we can just map this using this map, and then just create a tuple of this latitude, comma, longitude. Okay. Okay, it's sure return us the AQI response that we can just assign here. So let's just assign it directly rather than creating that let AQI response constant. And finally, we can set the location status to standby. Now just remove that commented code and try to build. Okay, the build succeeded. Now let's try this inside our preview. Nice, as you can see, now it fetches the data from the Google AirQuality API. So I think there are like 19 API calls, okay, for this. And I think to help avoid spike in our quota, right, billing, we can initialize this FU model, right? So for the sake of this preview, right, let's just limit the number of API calls given a radius. Okay. So let me check the radius, 4,000 and 8,000. So for the sake of this preview, let's just make API call, one API call in here, and for 4,000, let's just create a 2 API call. Okay, this is just 4 API calls. To make it much more, can also pass 1 if you want. Okay, this is 3 API calls. And if you want to also display or only the central location, we can actually pass an empty array to this. Okay. Okay, this will only make 1 API call. Okay, so be careful with this. Okay, I think when I commit this as a complete project, I will just set the array to be empty. Okay, so it just only shows the single location, as I don't want to spike other people billing costs, right? Because of I set that to too many API calls for the complete project. Okay, now this is rendered properly. Can see it shows the color as well the AQI index using the universal AQI matrix. So currently it's 22. So now we will need to implement the selection of this annotation to show the data, current conditions data given this coordinate. We're going to show this info at the bottom sheet using presentation detent. Okay, now let's implement the annotation selection for the AQI response. Let's go to the AppView model to hold the selection state. So here, let's just declare a var, give an array of selection, and set this as AQI response optional. Okay. Now let's go back to the map. So it's very easy to add this. We can simply add this selection, so it accepts a binding of map feature. In this case, we can just pass the selection, which is the AQI response. Now let's try to build the app. Okay, the build succeeded. And don't forget to enable the selection to be working properly. We need to add the tag property to the annotation view. Okay, in this case, we need to pass the AQI instance itself. And in here, we simply need to add the is selected. Okay, so we're just going to check if AQI from the parameter is equal with the VM dot selected selection, then it's going to be true, right? This is selected. Now let's build. We'll succeed it and refresh the preview. Okay, we got the preview. So when I tap this, it show the scale should be 1.5, right? Nice, as you can see. So this is the selected one, this annotation. Let me tap on this. Okay. Nice. So this works. We can also unselect by just tapping anywhere in the map, as long as it's not tapping the annotation. Okay. Now it's unselect successfully. Before we implement the bottom sheet, let's go back to the app view model, and in here let's create a var presentation d10. This will be used to control the head of that bottom sheet. So let's assign this with presentation d10 dot height. Okay, we're going to pass 176 as the default value. So basically our d10s we have multiple size, so we will have d10 with the height which the user can just pull down to show the full screen of the map, but it's not going to be dismissible, and then we are going to have this 176 height to show the information of the AQI condition as well as the text field later. Okay, let's go back to the view. Okay, so in the view below this map control, I'm going to add a sheet. Okay, I'm going to use this is presented, and here I'm just going to pass a constant of true because we are going to always show this bottom sheet. Okay, so this currently covers the full, it's using the default sheet, it covers the map. Now we're going to add an additional modifier to this. First thing is I'm going to add a scroll key. Okay, that's the root inside this sheet, and then I'm going to add a several modifier to configure this presentation d10. Okay, first one I'm going to add a padding to all edges. Second one I'm going to add a safe padding, area padding of top, and then I'm going to add a precision d10 passing an array of this, so 24, so the users can pull that down. Yeah, this is 24, and then 176, and we can also pass the selection binding passing vm dot presentation d10 state. Okay, so we should be able to control the presentation d10 head manually, programmatically. And then let's set the presentation d10 background. I think presentation background. For the background, let's make this ultra thin material. Wow, this looks good. And then let's add a presentation background interaction, so to enable the background interaction so the user can still drag around the map. So we're going to pass enable up through, we're going to pass our maximum height, which is 176 for this d10, right? So with this the user should be able to still drag the map around. Okay, and finally we need to add this modifier interactive dismiss enable. So basically the user won't be able to drag this, dismiss this bottom sheet. Okay, we're using this interactive dismiss enabled. Okay, this is our initial d10. Now let's implement the content inside the scroll view. Currently, as we are modifying the preview, it will make the API call. I think we should create a mock, but for the sake of simplicity and time of this tutorial, I'm just going to comment this preview. So it's not making API call as we modify the view. Okay. So now let's create another function that will return a view for containing the AQI response details. Okay, just give it a name of selected AQI view with one parameter, AQI response. This should return an opaque view. And then let's just declare an edge tag in here. Just add a padding of top, and let's also add horizontal to the padding and set the frame max width to infinity. So inside the edge tag, we can simply use the circle AQI view again, passing the AQI from the param, and in this case I'm going to pass an size, passing CG size of, make it a bit larger in here, 80 by 80. And then let's also declare a v stack with the alignment of leading. I'm going to show several information. First one is the coordinate. Okay, just use a string interpolation, passing AQI.coordinate.latitude, and then comma, AQI.coordinate.longitude. Okay, and then below that, just going to show the category and dominant pollutant. I'm going to pass AQI.dominant pollutant. Oh, a key response cannot be found. I need to import this XCAAQI. Okay. And finally, just going to show the AQI display name. Now let's go back to the scroll view in here, and then let's declare a v stack. So if selected AQI exists inside the vm.selection, we're going to just declare the selected AQI view, passing the selection. And in the else block, I'm going to check if vm.location status equal to requesting AQI conditions. I'm going to just show a progress view with a label requesting current AQI conditions. Requesting AQI conditions. And let's also do this for the requesting location. Change the label to requesting current location. Okay, and let's also add a if case select to location not authorized. So I have tried to use switch, but in case of my current previous attempt, it failed to compile this code properly. So that's why I'm using if in here. Not sure why. Swift compiler is not able to analyze this expression when using switch. Okay, let's use the same for the error. Okay, so we have all of this. Now we should be able to try this. Okay, now let's try to show the preview. First one, we need to uncomment the preview. Okay, now we got the preview. Refresh this. I added this to fetch these 3 coordinates. So yeah, requesting API client. And as you can see, now we have this. Let's select one of the coordinate. Nice. As you can see here, it shows this data. 19, 22. Okay, coordinate, low air quality, the dominant pollutant, as well the current matrix for the AQI that we are using, which is universal AQI. Okay, I think this is, we need to add a bit more spacing. in between here. Let's add a spacing of 8. Okay, it's making API call again. Okay, I think this is better compared to the previous one. Maybe 16. Yeah, I think 16 is better. Okay, so that's it. We have implement the selection in here. So when this we tap outside of the selection, it will unselect and it will just dismiss the selected AQI view. So the next step is to add a form view where the user can enter their latitude and longitude manually, which we can use to make the API call. Calculate the coordinates given to that location, update the camera position to that coordinate, and fetch the conditions to the Google AirQuality API given that coordinates. Okay, so let's do it now. It will be the final stage of this video. Oh, one thing that I miss in here. So let's say I set this precision detain height to the 24 height. So when I select this, I should expect the precision detain height to be adjusted to 176, right? But currently it's not, right? So it's still showing this, right? We need to do it manually. So let's add a modifier. Okay, here let's add this on change of can pass vm.selection. Will pass the old value and the new value. Okay, in here we can basically check if the old value is nil, which means it doesn't exist, and the new value exists. Currently mean we are currently selecting something. We are going to set the percentage detain to height of 176. Okay, so dismiss, not dismiss, set it to 124 height and select 1. Nice, as you can see, it set the detain to 176. Okay, so put this, get this again, select. Nice, this is the thing that we want. Okay, now let's begin implementing the form to enter the latitude and longitude. First thing, I'm just going to comment this preview again to avoid making API call as we update the view. Okay. First, let's go to the app view model and let's add two additional properties. Lat, this should be a double. Let's assign the default value of 0, and long double. Let's also assign it with the default value of 0. Okay, now inside this content view, let's begin by creating another var inner location form view, sum view. We're going to use view builder in here. And now let's just declare a first text, get current AQI around a coordinate. Set the font to headline and set the padding with the bottom of 8. Let's declare h tag, and then just for the label, let and text field, enter the latitude. For the binding, we should use this value, passing the binding of vm.lat, and let's also pass this number as the format. So this will format the text field to use only accept number. Okay, but remember the user can still paste using a hardware keyboard as a letter, right, if they want. So you need to be careful with that. I'm not going to handle the validation properly in here because it will take some time. Okay, but basically this will just update the value in this lat in case the number in this text field can be parsed to double, right? Okay, or a float. And let's do the same For the longitude, change this to long, enter longitude, update this to use vm.long, and let's add a keyboard type of decimal pad. Okay, and set the text field styles to rounded border and add a padding with the bottom of 8. So using this format, we need to make sure when the user enters the comma, it uses the comma symbol instead of dot. Okay, when the user enter using a dot, it will be not accepted properly. Okay, so you need to update that dot with the comma. Okay, that's one thing to notice. And below this, we're going to add a buttons inside the h tag. First one is button to use current location, current log. In this case, just set the vm.lat in the text field to vm.currentLocation.latitude, as well as the lone. Okay, so this current location will be updated based on the core location manager did update callback. Okay, this will be based on the GPS data. So we track that inside the current location property. And then after this, we're going to just refresh using vm.handle coordinate change passing this init of latitude, vm.lat and vm.lon. Okay, looks good. And let's set the button style to bordered prominent. And the button beside that will be a refresh AQI. In this case, I'm just going to copy and paste this, and in this case, I'm going to pass just same vm.lat and vm.lon. Okay, set also the button style to bordered prominent. I think we got the view. Now we can uncomment the preview to test this. Okay, let's just rebuild in case you got that error. Sometimes that happen. Okay, build succeeded, and then refresh the preview again. So we got the view rendered, but I forgot to actually add that inside this bottom sheet. Okay, so in the bottom sheet, in the else block, we're going to add if vm.location status is not equal with the requesting location, and vm.location status not equal with requesting AQI conditions. Only in this case, I'm going to show this location from view. Okay, as you can see, the text fields are rendered, the form with the buttons. Okay, now let's try inputting a location. So you can use this website gpscoordinates.net to find coordinates given an address. So let me find coordinates in Tokyo, Shinjuku. Okay, so remember this is using dot, right? As I said before, you need to update this to use comma, otherwise the input won't be correct. So let's change this to comma and then copy and paste this. Okay, so this is the lat. Okay, so now let's just click this refresh AQI. Nice, as you can see, it navigates, update the camera position to Shinjuku, and it fetch the locations, the air conditions around the coordinates. Okay, nice. Wow, the air quality in Tokyo is just so good, right? Dominant pollutant is O3, good air quality. Okay, we have implemented this latitude and longitude form where the user can enter the latitude and longitude to find the current air quality conditions around that location. Now let's move on to the final stage, which is to implement the CL location manager to access our current locations given the permission of users. Let's navigate to the app view model. The first thing is let's declare a location manager lat here and initialize this with the CL location manager from the core location SDK, okay, API. And inside the initializer, so I think I need to be careful in here. Let's provide default value of 1 and 1. So just 3 API calls by default instead of 18, 19. Okay. And now we can remove this stub of current location. Okay. We don't need this. We're going to fetch the current location using the CL location manager. Okay. But first thing before I forget is we need to ask permission to our users to access the location. Okay, we need to be a good citizen. Okay, and also respect the privacy of our users, right, when using the app. Ask for their consent. Okay, privacy. So we're going to use location. We're going to just use when in use usage. Okay, we don't want to always access the user location to avoid wasting their battery life as well, right? Okay, the app wants to show AQI conditions around your location. Okay, so this is the message that will be shown to our users. Okay, we have add this permission in the info plist. Next one is we need to make this as a subclass of NS object because we're going to create an extension for this app view model that conform to the CL location manager delegate. So we can receive callback in case for any change in the locations. Okay, first thing in the init, we need to call super init because now we are conforming to NS object. Okay, super init, and then call manager dot location manager with delegate equal to self, and we need to also invoke location manager request when in use authorization. Okay, now we need to implement this location manager did change authorization. Okay, in this case we're going to use switch manager dot authorization status in case of when authorization when in use is granted by the user. We can invoke manager dot request location. Okay, and then for the default case, let's set the self.location status to location not authorized, passing the string unauthorized location access. Okay. Oh, there are too many C. Okay, location manager did change authorization, and next one also location manager did fail with error. So here I'm just going to set the location status to error. Okay, just a generic error, passing error.localized description. Remember that even when the user does not authorize to give the location, the user can still use the app, right, by just entering the latitude and longitude manually inside the button sheet, the form in the button sheet. Okay, so that's one thing. We'll have to respect the privacy of your users, right? Even if they don't want to give their location, we still give them the access to our app. Okay, enter the latitude and longitude manually. We're not tracking you. Okay, that's one of the principle, I think, that we should respect privacy of our users. Next one is location manager did update. What's the name? Did update location. Okay, this will be called when the location got updated as the user moving. Okay, so in this case I'm going to just use the guardlet coordinate. I'm going to get the first location in the array coordinate, else I'm just going to return in case the array is empty. Second one, I want to check, right? So as you can see, the current location initial value is optional, right? It's nil. So only when the current location is nil, right, I'm going to assign the lat to coordinate.latitude. This will update the text field, the longitude as well in here. And in here, I'm going to kick the task to fetch the current AQI condition given this coordinate. Okay, so this will be invoked only the first time we got the location data when the user launch the app, in case they give the permission. If not, this won't be executed. Okay, handle coordinate change, we can simply pass the coordinate, and regardless of this, we'll need to update this current location with the coordinate. Okay, forgot to invoke wait. Okay, everything looks good. I think I need to add main actor in here to make sure the UI got updated in the main thread. Okay, as you can see, this is an async method, right? So main actor, make sure the UI, all the properties that get binded through the UI got updated in the main thread to avoid any crashes. Okay, I think everything looks good. We can try this, but one thing, actually, when I tried this using the SwiftUI preview, right, the CL location manager doesn't really work. So I think we need to try this using a real device, physical device, or simulator. Okay, remember that using simulator, you can simulate the location in the simulator options. So let me just use simulator for now and then run this. Okay, as you can see, it shows this window asking for the location. So allow while using the app. Okay, so currently I set the location to Jakarta. Okay, so you can set the location using these features and select the location and enter your custom location. It will provide you with that latitude and longitude that you can provide. So this is very similar like the text field in our app, right? Remember that you also need to pass comma instead of dot. Okay, so works. Get the requesting the location from our users. When granted, it will use that location to fetch the initial location and the current AQI conditions. Okay, everything looks good. And yeah, this is the default fail. Currently, it's only fetched 3 API calls, right? But remember, we can update this like to 16, 12. Okay, so this will be counted to 19 API call requests to the Google AirQuality API. So need to be careful on that. Okay, so let's say I change the location to Apple. So it should be around Cupertino. And let's rebuild this again. Okay, so now it shows the location, air quality conditions around Apple headquarters in Cupertino. Okay, this looks very good. Okay, excellent air quality. Wow, 83. This is amazing. Wow, compared to the air quality in Jakarta, right? It's very bad. And the dominant pollutant is O3 as well. Okay, it's better much better compared to PM25, right? Okay, I think that's it for this tutorial video. We have successfully built this air quality index app to get the current air quality conditions given our location. And yeah, as you know that the current climate conditions is getting worse, the air quality is getting worse. Day by day, we breathe those bad air quality. So we need to be aware, we need to keep our environment healthy in the long term. We need to sustain the environment for our future generations. Okay, so that's it for this short video. I won't talk too long about this sustainability in the long run, but I encourage you to keep in mind for our future generation, right? So like the video, like, subscribe if you haven't, and thanks for supporting me. And let's keep on being a lifelong learner. And until the next one, goodbye.